Hello, 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 and welcome everybody to another day of math. Happy Monday, happy December, happy last school week of the year before winter break. Last school Monday in 2020. Whew, it's a big one. We're almost to a well-deserved little respite before we jump back into things in 2021. We're almost there. A lot more work to do this week though. Today, we are introducing the coordinate plane. It sounds fancy. It sounds like we're like going to space or something. Next stop, the coordinate plane, something like that, you know? But really, it's kind of something you might have seen before or been introduced to before. It's another way to, again, visualize data or information in a mathematical context. Okay, here's what you're going to need today. Something to write on, something to write with, and then also if you have graph paper and a ruler at home and handy, it can help when talking about the coordinate plane when graphing coordinates, but they're not required or necessary to understand this lesson. Again, it's going to be just kind of an intro today, so less kind of the doing of the stuff on paper as we go and more of the, you know, looking and listening and watching, and then your iReady exit ticket, you're going to get to dive more in depth into it. And then here are the I cans today. I can use a coordinate plane to find the distance from the origin, we'll talk about what an origin is in just a second, to a point on the plane, and I can name a given point on the coordinate plane. So as we get into it, again, the coordinate plane really just refers to another way, another tool that allows us to sort of visualize or to see information in math, just like a data table, just like a tens frame, just like a number line, right? Essentially what a coordinate plane is just two number lines that are perpendicular to one another. It can be very useful. So right here behind me, this is what the coordinate plane looks like. And if I zoom in, you can see I'm on grid paper here. So I've got little squares here. Those will be important. But zooming back out, for now, the coordinate plane looks like this. We're actually kind of only seeing one section of it for now because we haven't gotten into negative numbers. But this is kind of our first introduction to it. Okay? And essentially what we have here are two number lines. A number line here that, because it's a line, can go infinitely off to the side there. Okay? I'll finish that arrow just so it looks a little fancier on video. Ta-da! Okay, and then we have another number line here. This one is vertical. And again, since it's a line, it goes infinitely in each direction. And the nice thing about having two number lines set up in this way, set up perpendicular to each other at a 90-degree angle, is that now we can start to show space and we can start to show distance in two dimensions, okay? Not just on one line, but on two at once, okay? A great real-life kind of version of this is if you're looking at a map or you're looking at a, you know, could be a road map, could be a world map, and being able to see, if you'll notice on many maps, they'll have sort of grids at the top to help find what, to be able to find and locate where different places are on the map. It's a little different. We don't see physical maps as much nowadays because of the internet and because of Google Maps, okay, Google Maps doesn't have a grid, right? Which is unfortunate because we do lose that piece of learning there and that kind of real life connection to the coordinate plane. Okay, and essentially what it's showing is distance. Down here we have, and I'll zoom in, okay, on right here where the two, we call them axes, the x-axis is the name for the horizontal one, the y-axis is the name for the vertical one. Okay, right here where they intersect, that point is called the origin. Okay, and that's going to be our starting point. Essentially, that's the start on our map. Okay, if we were looking for buried treasure, this is where we would start. Okay, and the coordinates of this are 0 and 0 because we've gone 0, essentially we're at 0 on this number line, and we're at 0 at this number line. Okay? And to find the distance on the coordinate plane, sorry, I'm moving around a lot today, but I do want to be able to zoom in so you can see. To find the distance on the coordinate plane, all we have to do is know how far we have to travel on this axis, how far we have to travel on this axis, on this line, essentially. Looking in the chat, how many squares by how many squares, it actually does not matter. The more you can fit, the more space you have to input data. But for now, you know, I see 10 by 10 is fine. Okay, if your whole page is 50 by 35, that feels like a lot. So make a mathematical judgment on this. Again, we're just kind of introing it today, so there isn't a limit on what we're going to need as far as our coordinate plane here. Okay, so let's say, for instance, let's imagine, if you will, the origin right here, that's your house. Okay, and then we're going to make this point here, okay, we're going to call this, we'll call it G for the grocery store. Okay, so if we're imagining, hold on, let me take you down here. If we're imagining that this point G is the grocery store, and we need to know how many blocks, how far we need to travel to get to the grocery store, this is where we can use our coordinates. So, starting from the origin, we're going to walk in. Let's imagine that each one of these squares is a city block, let's say. So how many blocks do we have to go to the right? How many blocks do we have to go up to get to the grocery store? Let's count. Ready? 1, 2, 3, 4, 5, 6. We've gone 6 blocks to the right along our x-axis, and then 1, 2, 3 blocks up on the y-axis. Okay, so how many blocks total did we travel if we went 6 to the right plus 3 more up? How far did we travel? Yeah, we traveled 9 blocks. Okay, and the way we show where this point is, because we can't just say, you know, to go to the grocery store, go 9 blocks, but it's because it's like, wait, in what direction do I go 9 blocks? I could go 1, 2, 3, 4, 5, 6, 7, 8, 9. I went 9. There I am right here. Is that the grocery store? No. I could go 9 blocks up. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Am I at the grocery store? No, the grocery store's on the other side of town, way over here. So we need to be exact and we need to be accurate when we're talking about where a point is on the coordinate plane. So what we're going to do, these 2 numbers here, these are called ordered pairs. Okay? Our pair of coordinates that tell us how many steps or how far, what distance to travel along the x-axis, what distance to travel to the right, and then what distance to travel up. Okay, so for this one, how many blocks did we travel sideways? How many blocks did we travel along the x-axis? We went 6. And then how many did we go up? 3. So we would call this point G, we would call it 6, 3. Showing 6 blocks up, or 6 blocks over, excuse me, 3 blocks up. Okay, let's try another one. Let's say we wanted to go, put it up here. Let's say we're going to call this S for school, way up here. Take us back up here. Ta-da. So how many blocks do we need to go over? How many blocks do we need to go up? Okay, so going over, 1, 2, 3, 4, 5. And then how many blocks up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 5, comma 11, showing 5 blocks over, 11 blocks up, and then how many blocks total did we have to walk? Yeah, just add them together. 5 plus 11 equals 16. Let's try a couple more. And in fact, this time I'm going to give you the coordinates. And I want to see if you can find where they are on your coordinate plane. So the first one, hold on, making sure I switch from, there it is, making sure I switch from Sharpie to whiteboard marker, because that would be not fun if I wrote on this in Sharpie. So see if you can find the point 8, 7 on our coordinate plane. Remember, we're always starting from the origin. We always start from 0, 0. Always start from 0, 0, and then where is 8, 7 going to be on the coordinate plane? So think about, with this 8, do you go 8 up first, or do you go 8 over first? And if you're not sure, or you don't have graph paper, you can describe it, right? How many blocks would you go over, or how many steps over, and then how many steps up, okay? Just a sneak peek for some of you that are interested. Once you get into middle school and we start covering negative numbers, this is only going to be one quadrant of our coordinate plane, because there's going to be negative numbers that are less than 0 on both the y-axis and on the x-axis. And then there's a quadrant over here that's negative on both. So this is kind of just the first step, okay? So we see a few people. Yep, I see 8 to the right and 7 up. So let's zoom down and zoom in here. There we go. Okay, so we're going to go 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8 to the right. And then 7 up. 1, 2, 3, 4, 5, 6, 7. We'll call this L for the library. Okay, so taking a look at our coordinates there. Now here's a question. Let's see if we can figure this out. How many blocks would it take us if we wanted to go from the library back to the grocery store? Let's say we went to the grocery store, picked up breakfast, went to school, went to the library after school, and now we've got to go back to the grocery store because we need to pick up something for dinner. So how many blocks, I'll zoom in even further as far as I can here, how many blocks would you have to go to get from the library to the grocery store? And you have to walk along our streets here. Can't go through people's houses. There's a couple ways you can do it. You can measure it out or walk it out, or you can use addition and subtraction to figure this one out. How far would it take, or how far do you have to travel to go from the library to the grocery store? How many blocks? Yeah, I know the blue lines are hard to see. We'll try and find some better grid lines next time. Or I might use the digital whiteboard for this next time. So let's think about it. Let's think about it in mathematical terms. Even if we didn't have the lines here, we could still calculate this. Okay? For instance, what's the difference between 6 and 8? If I was on just our x on the number line, how far would I have to go to get from 6 to 8? What's the difference between 6 and 8? Yeah, 2, right? 8 minus 6 is 2, and there's our 1 step, 2 steps. Now, let's look at the y-axis. What's the difference between 3 and 7? 3 plus what is 7? Or 7 minus 3 equals what? Inverse operations, right? Yeah, 4. 1, 2, 3, 4. So you'd have to go 2 blocks over, 4 blocks down, for a total of 6 blocks. Let's see. We also had, Ava in the chat is noticing if you had, let's see if I'm reading this right. Ah, I see. So in the chat, we're actually making a point that if we were walking from the origin or from home to the library and then to the grocery store, it would be a total of 21 blocks. The 15 it would take to get to the library, and then the 6 more it would take to get to the grocery store. Nice. Okay. And also in the chat, people reminding, as a helpful hint, the x-axis going across comes first, because x comes first in alphabetical order. That's a good way to remember that. Okay? And also, across comes first in alphabetical order before up or down. So, another good way to remember. All right. Thank you, everybody, for coming. Reminder, the exit ticket, which just posted on Google Classroom, is an iReady exit ticket. We're going to be doing some more work around the coordinate plane, and it's going to give you kind of an interactive coordinate plane there, so you don't need your own graph paper for that, which is one of the reasons why we're trying it on iReady today. So make sure that you're going to iReady through Clever, or you can go through the exit ticket on Google Classroom. Complete the activity, and then mark your Google Classroom assignment as done when you are done. As always, the office hour will open up at around 11 o'clock. Thank you for tuning in. We will be back tomorrow with some more work around the coordinate plane, in particular talking about our ordered pairs here and kind of how they work together, and then doing some more graphing. All right, thank you everybody, and happy math, and we will see you soon.